Hello, so today we are going to do this problem, which is part of Leetcode daily challenge. Number of zero-filled subarrays. So basically with this problem, we have an array, and we want to return the number of subarrays that are filled with zeros. And of course, subarray is contiguous set of elements and has to be non-empty. It's not a subset where you can skip elements. It's a contiguous. So if we take the first example, we have this subarray that is only zeros, and this subarray has 1 0. This one 0 alone, it can be a subarray. This 0 alone can be a subarray, and then the 2 should be counted also as a subarray. And similarly here we have 2 individual 0 subarrays, and then 1 with 2 0 subarrays, with 2 0 subarray, right? And so that means we have 4 instances of just 1 0, and then 2 instances of 2 zeros subarray. So we return 6. So that's sort of the idea. Now how do we solve it? Okay, so how do we handle it? Well, the easiest way to do this, we can't actually do backtracking with take or don't take, because we want a contiguous subarray. We don't want to skip elements. So how do we tackle that? Well, the first thing to know is that if you have any subarray with any number of elements, how do you know how many subarrays are in this subarray? Well, you can just use the formula n multiplied by n plus 1 divided by 2. That will give you the number in this one. So for example, this one is equal to 3. That would mean here we have 3 multiplied by 4 divided by 2. So 3 multiplied by 4 will give you 12, and 12 divided by 2 will say 6. And this one has 1, has 2, has 3, and then it has 1 2, it has 1 3, it has 1 2 3. So 5 6 subarrays overall. So from this idea we can actually solve this problem. How? Because what we can do, we only need subarrays filled with 0. So what we can do is get the max contiguous subarray with zeros, right? Basically max streak of zeros each time. So that would mean, for example, here we can just get the max streak, which is these 2 zeros, and then from the length would be 2. So the streak would be 2. From that we can tell how many subarrays are in this subarray and just count those. Okay, so that would mean, let's apply it here, and once we encounter a non-zero, reset our streak, and then once we encounter 0 again, start counting our streak, and then once it ends, account for how many subarrays in that streak. Okay, let's run it on this example and just make sure it's clear. So we have the overall count, and then we have the current streak, right? Let's call it just streak. So both initially 0, and as long as the array is, so we'll keep going until we find a 0. So this one, non-zero, we continue, non-zero. When we find a 0, we increment our streak. We find another 0, we increment our streak. Now when we find a non-zero, we should count how many subarrays were from that streak. How many from that streak? Well, it's just 2 multiplied by 2 plus 1, which is 3 divided by 2. So remember this formula. So that will give us 6 divided by 2, that will give us 3, right? And so here we add 3, okay? And now we need to reset our streak once we find a non-zero, because we already counted it in our count here. So we reset it. Now we find another 0, so we increment our streak. Another 0, we increment again. A non-zero, and so we need to account for this streak. So 2, we add another 3, we have 6, and we set this to 0. Okay, and that's pretty much it. We can return the count, and you can see this is actually all in time, so it should be pretty easy. Now there is one, we do this in a loop. There is one edge case we should remind ourselves with, is what if the array ends here, right? So we end with 2. So at the end of the array, we won't find another non-zero value, right? So we just need to make sure that at the end of the loop, we check if our streak is bigger than 0, has not been reset yet, which means it ended with zeros if it has not been reset. And so we will just need to take care of counting it. And so we'll count, and then it will be 0 again, and then we'll get 6. We'll return 6. So that's sort of the idea. So just taking advantage of this formula, and then doing a one linear scan. Okay. Yeah. So now let's implement this logic. So that would be, first we need our streak counter, and we need our count, and then we go through the array. Okay. Now, if the number is 0, we need to increment our streak. Otherwise, we need to check if our streak is 0, we need to add it, right? And so we can do if streak is bigger than 0, we need to add to the count using this formula here. We just replace with streak because that's the number of elements, multiplied by this, divided by 2. Okay. Now, when streak is 0, this will be 0, so we actually don't need to check if it's 0 or not. So we can just do it like this. And then we need to reset our streak because we just added, because the subarray just ended, right? We are here, so we need to reset it, equal to 0. And then at the end, we need to return that count, except what I said, we need to manage the case where it ends with zeros. And so to do that, we want to check if streak is bigger than 0, we want to add it to count. Do the same thing like that. The other way to do this, to avoid having to do this check, which is a pretty useful trick, is to just add a non-zero element at the end of the list. So let me actually just first submit and show you how to do that. So this passes. And now let's do that trick that will eliminate this. So we can just have our nums, just add some placeholder, doesn't matter, any number, because here we only care about zeros, right? So maybe add 1. That way we guarantee that the last element is always a non-zero. Okay, so let's do that, and then we can remove this and we can submit, and this passes. Okay, so that's sort of just a clever idea to avoid handling edge cases. Now, what's the time complexity? As we said, the time complexity of this loop is O(n), so overall it's O(n) time. Space, we are not really using any extra space except these variables, so it's O(1) space. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.